Hello everyone, my name is Wouter Pere and I'm the founder and main developer behind GHEtool Cloud. In today's video we will talk about hybrid systems. Now today is the first video about hybrid systems, but we have planned a couple more. It will be a series where today we will be talking about what exactly are hybrid systems, and we will also be introducing the concept of geothermal potential. Geothermal potential is an important topic when it comes to the design of hybrid geothermal systems. In part 2, which we will publish next week, we will talk about the design methodology itself. It will be a more theoretical video where we will be discussing the different methods that are implemented into GHEtool and how they relate to hybrid system design. The week after, we will publish part 3, which will be more practical. Here we will go into GHEtool Cloud and we will discuss how you can use GHEtool to design your hybrid geothermal systems and how you can play around with it and come up with the best design possible. And optionally, we will create a part 4 discussing more about the economics, the benefits of a hybrid system design from an economic point of view. But let's get started with part 1. So what exactly are hybrid geothermal systems? Now imagine you have a multi-utility building. This can be anything ranging from a residential building in combination with, for example, a store or an office building. Typically a building with a lot of heating and cooling power. So in this case we have a building with 536 kilowatts of heating and 676 kilowatts of cooling. And we enter this information into GHEtool Cloud and we end up with a bore field of 130 boreholes. But perhaps it can happen that we have not enough space to drill this 130 boreholes. As you can see here, we have a project that has not quite a lot of space. Perhaps you can drill under the building, but it's not that sure. So perhaps we cannot drill 130 boreholes. Or we have not the budget to drill it. Boreholes are rather expensive. It's often the most expensive part in our total HVAC system. So perhaps we do not have the budget to go all in on geothermal. Or perhaps it's not financially ideal. Perhaps there are other solutions that are more promising from an economic point of view. So that's exactly what hybrid systems are. If we have on the one hand our building demand, which we can deliver with our bore field, with our ground source heat pump and our heat exchanger for passive cooling, then we say that we have a 100% geothermally cooled and heated building. But in the cases mentioned before, we can also go for a hybrid system, where we say, well, next to the bore fields, we place other technologies. For example, an air source heat pump, or solar thermal collectors, or perhaps it's a renovation and you still have a gas boiler left. So in this case, the bore field will only be part of your heating and cooling solution. And that exactly is a hybrid system. So a hybrid system basically is any system which is a combination of multiple technologies to heat and cool your building. So in case of a geothermal hybrid system, there is always a ground source heat pump and you can combine it with, for example, an air source heat pump or with solar thermal collectors if you want to regenerate your bore field and lower the imbalance. Or you can combine it with an air source heat pump and a dry cooler. It really all depends on the building you have in your case. Now, a hybrid system has a couple of advantages. First of all, you will be able to minimize or optimize your investment costs. If you combine different technologies, then you will be able to select technologies which have mutual benefits. So the bore field typically is the most expensive technology in your own HVAC system. So perhaps if you combine it with, for example, an air source heat pump, you can make it smaller, so you save there some investment costs. And that can be interesting to make a geothermal or hybrid geothermal system more feasible in the end. But also you have a more durable design, because when you have a hybrid system, you have multiple technologies. So if one technology, one way or another, fails, you still have the other technology to heat and cool your building. So this is somewhat related to the question of backup technologies and backup power, where it's always more beneficial to have a certain backup installation in case something goes wrong. So the question now remains is how you design such a hybrid geothermal system. Well, you can say, well, we have a building demand, and part of it we can meet with our geothermal system, and we have a certain combination of technologies for a hybrid part, but you can always have a smaller share of the bore field or even a bigger share. So the question is, if we have X boreholes, what geothermal share can I achieve with that system? And that's related to the topic of geothermal potential. So what is exactly geothermal potential? If we take a look at this temperature profile below, if you have not watched our videos on the interpretation of temperature profiles, it's linked in the video description below. And if we take a look at this figure, we can see that we reach the maximum fluid temperature limit in the first year of operation for cooling. But on the other side of the figure, in the last year of operation, we do not reach the minimum temperature limit. So we can say that there is still potential here. We can install some extra heating power on a bore field. We can increase our geothermal heat pump to extract more power from the ground. So yes, there is potential for this bore field for extra power because we do not reach the minimum temperature limits. So when we do that, we end up with a figure like this one, where we now reach both the maximum and the minimum fluid temperature limits. So well, now you can say, well, we cannot install any more power because we're limited by both temperature limitations, and that's it. But as you can see, in the last year of operation, we do not reach the maximum temperature limit. So we can easily inject more heat into the ground, we can provide more cooling to our building, and in the first year of operation, we can do the same with heating. So we can extract more heat in these first years of operation to heat our building sustainably. So in this case, we say, well, we have potential for extra energy exchange. So if we install a slightly bigger heat pump, we can extract more heat in these first years of operation. Not in the last, because there we're already limited, but in the first year of operation, we can have some more geothermal energy. And if we do so, we end up with the figure on the next slide, where we now reach the temperature limits in every year of the simulation periods. So now we can say there is no more potential left because we exchange all the energy all the time with the ground as much as possible. So if we summarize this and we go back to our hybrid design, we basically can use our bore fields, or we can design our system in such a way that we use our bore fields in either the left way or in the right way. If we use it like the figure on the left, we can be sure that if we install a certain amount of power for the bore field, that we always can get that power. So if we have our building with 536 kilowatts of heating, if we say, well, we install 200 kilowatts of geothermal power and it gives us the profile above, then we know that we only have to install 326 kilowatts from another technology. This makes sure that we have the lowest investment cost as possible, because the sum of all the powers we install is just our building demand. So there is no oversizing. But as we saw on the previous slide, there is still some geothermal potential left, namely in the first years in heating and in the last years in cooling. And because there is some geothermal potential left, our system efficiency is most probably lower, because geothermal systems have the tendency to be very efficient, and if we have to rely more on our hybrid system, chances are our total system performance is lower. And this also means that if we design in such a way that our operational expenses will be higher. Now, if we compare it to a hybrid system that's designed like the one on the right, here we see that there is no geothermal potential left, because we reach the temperature limitations in every year. This also means that since there is no potential left, we extract or exchange as much heat with the underground as possible. So we will have the highest system performance, and we will hence have the lowest operational expenses. But on the other hand, which is the downside of such a design, is that we can't be sure that we will always get 100% of the installed power from the ground. Because we've installed extra power to exchange the energy in the first years and in the last year, but the power we can get from the ground in the first year is different from the one in the 10th year or in the 20th year. So we have to compensate for that in our hybrid system. So let's say that in this case we install, for example, 300 kilowatts of heating of ground source heat pump. Then we know that in the end we won't be able to get 300 kilowatts out of the ground. So we have to compensate for that with our hybrid system, so that in the end we end up with a total installed power that's higher than our building demand. We hence end up with a higher capital expense because our system is oversized. Now, perhaps you all also want some backup installation, and then this is not necessarily a problem, but that's a detail we will be covering in a next video. So this was it for today. In the next video, which is part 2, we will be discussing some methodologies for hybrid system design. I hope you found this video interesting, and I'm looking forward to meeting you in the next one. Take care.